Here's an interesting fact about Booleans. Internally, true behaves like the number 1. False behaves like the number 0. This means true plus true equals 2. True multiplied by 8 equals 8. False minus 5 equals negative 5. Although Python allows arithmetic using Boolean values, it's generally recommended to use this feature carefully. Code is easier to understand when Boolean values represent logical states instead of numbers. Since Booleans are related to numbers internally, comparison operators work exactly as expected. 0 is equal to false. 2 is greater than true because true has the numeric value 1. 2 is not equal to true. Negative 5 is not equal to false. These examples demonstrate how Python treats Boolean values during numerical comparisons. Let's explore comparison operators more generally. The double equals operator checks whether two values are equal. 1 double equals 1 returns true. 2 double equals 1 returns false. The exclamation mark followed by an equals sign checks inequality. 1 not equals 1 returns false because the values are equal. 2 not equals 1 returns true because they are different. Python also provides less than, greater than, less than or equal to, and greater than or equal to operators. Each comparison produces either true or false. These operators form the foundation of decision making in every Python program. Python also supports chained comparisons. Instead of writing 1 is less than 2 and 2 is less than 3, we can simply write 1 is less than 2 is less than 3. Python evaluates this as expected. If every comparison succeeds, the entire expression becomes true. If any comparison fails, the result becomes false. This feature makes comparison expressions shorter, cleaner, and more readable. Now let's discuss truthy and falsy values. Not every value is explicitly true or false. Python automatically converts many values into Boolean values whenever necessary. Several values are considered false. These include the number 0, empty strings, empty lists, empty dictionaries, empty tuples, empty sets, and none. Almost everything else is considered true. For example, the numbers 4 and -6 are both truthy. A non-empty string is truthy. A list containing values is also truthy. Understanding truthy and falsy values allows you to write cleaner and more Pythonic code. Logical operators have another interesting behavior. They don't always return a Boolean value. Instead, they return one of the original operands. Consider the expression 0 and 2. Python evaluates the first value. Since 0 is already falsy, Python immediately returns 0 without evaluating the second operand. Now consider -5 or 0. Since -5 is already truthy, Python immediately returns -5. This behavior is called short-circuit evaluation. It's used extensively in professional Python code for setting default values and avoiding unnecessary computations. Now let's move on to strings. Strings represent textual data. Python allows strings to be enclosed using either double quotation marks or single quotation marks. Both forms are completely valid. Strings can also be combined using the plus operator. For example, the string hello followed by the string world becomes hello world. Python even allows adjacent string literals to be automatically combined without using the plus operator. A string can also be treated as a sequence of individual characters. Indexing begins at 0. Therefore, the first character of the string hello is H. This indexing system is shared with many other Python data structures. To determine the length of a string, Python provides the built-in len function. Passing a string to len returns the total number of characters it contains. For example, the word Python contains 6 characters. The len function is useful for validation, iteration, and many other programming tasks.